The error x in digitizing a communication signal has a uniform distribution with probability density function given as shown here. We want to sketch the graph of f of x. So it's going to go from negative 0.5 to 0.5. So this would be f of x, this would be x, and of course it does this. And so that's our sketch. What's the probability the error is at least 0.35? One thing I forgot in part A, of course, if the width of that is 1, the height of that is 1. That's kind of important. So what's the probability the error is at least 0.35? So 0.35 is there. It's just going to be that area. Now if this is 0.35, that means the width of that rectangle is 0.15 and the height is 1, so it's going to be 0.15. If the error is negative, so this is now a conditional probability, what's the probability it's less than negative 0.35? So that is going to be the probability that x is less than negative 0.35, given that x is less than 0. So to be less than negative 0.35, that's going to be 0.15, which is the area of this rectangle just here. But probability of x being less than 0, of course, is 0.5 here. So this one is going to be 0.3. An engineer is more interested in the square of the error. What's the probability the square of the error is less than 0.09? Well, if the square of the error is less than 0.09, then the error itself is going to need to be between negative 0.3 and 0.3. Because if you square either of those, you get 0.09. And if the number is between there, when you square it, it's less than 0.09. And so that's just the width of a rectangle, going from negative 0.3 to 0.3. If the rectangle's got a height of 1, that area is going to be 0.6. Calculate the variance of the error. Well, in general, we know that that's the expectation of x squared. Take away the expectation of x squared. But of course, this bit here is going to be 0 because we have something symmetric that's centered on 0. So what we're going to do is we're just going to have the integral. Remember, expectation of x squared is x squared f of x dx. So that is going to be from negative 0.5 to 0.5. And of course, the function itself is of height 1. So it's just going to be x squared dx. So that is going to be x cubed on 3 to be evaluated from negative 0.5 to 0.5. So if we have a half and we cube it, we get 1/8. So divide that by 3, and that is 1 over 24. And if we put negative 0.5 in here, we're going to get negative 1 over 24. And so that is 2 over 24, which is 1/12.